this is the first time you're hearing it, this will be a great day for you to hear it because this is a strategy that you will be using for the rest of your life. So consider this to be a super exciting day, right? Okay, how many of you have seen this here on the wall though? Okay? It's an acronym for problem solving. So what is problem solving? Okay? The process we're going through today does not necessarily justify what we're going to be doing every time we see a math problem. Okay? Because sometimes you see a math problem and you know how to solve it and you can work your way through it. But this is going to be especially important when you don't know what to do. How many of you have ever had a problem that you don't know what to do in that problem? Have you ever seen a math problem and you're like, I don't know what to do? Okay, that's everybody, including myself. Okay, been there, done that, look at a problem, you're like, oh snap. How many? Okay, the first letter that we have is the U. What does the U stand for? Understand. Okay, ladies and gentlemen, believe it or not, I am a reading teacher. I'm not certified reading, but I am a reading teacher because how many problems in math have reading? All. Okay, they're all there, right? You open up your STAR test, you open up a regular test, you open up your home, you look at your homework. All of those have word problems on them, right? I'm going to teach you how to analytically read. Okay, no one reads a word problem and says, what is the author's intention? What did the character development here tell us about how he feels? No, that is not the type of reading I'm going to teach you. But what I am going to teach you is I am going to teach you the kind of reading that you can read to succeed with in math. Okay, first off, when you come to a problem that you don't know, how many times do you think you read that question on average? 3. 4 times, 2 times, 3, maybe 5. Can I explain to you what your brain is doing when you read that over and over again? First time, number 1, that you read something. Jack and Jill went up a hill with 3 pails of water. Jack went over the hill, tripped down, and 2/3 of his bucket fell out. What did you get out of that problem the first time I told it to you? How many of you were more focused on imagining that Jack and Jill are going up this hill, fell down, and you're picturing how he ate it in the grass, slid down mud, right? How many of you were focused on that rather than there was 2/3 of his bucket that fell out? That is what your brain does naturally, ladies and gentlemen. It wants to know what's going on. It's right. So that third time, ladies and gentlemen, you are finding out what you need to do. So Jack and Jill went up the hill to fetch 3 pails of water. Jack fell down, spilled 2/3 of it left. How much water do they have left? Now do you have a purpose? Now do you understand what you might need to do? That, ladies and gentlemen, is the reason why you read it 3 times. Because your brain goes through this process as it's looking at math problems, saying the first time, what's going on? The second time, where's my information? And the third time, so what am I going to do with it? Is everyone on that page? That's all about what our understanding is. Okay? Then what comes up next? A plan. So now, we already have our story situation, right? We understand that we need to find the answer, which in our case, Jack and Jill went up the hill to get 3 pails of water. Jack and Jill slipped, spilled 2/3, and what are we trying to figure out?
How much is left?
That, ladies and gentlemen, is where we come up with our plan. You pick a strategy. Are you going to draw a picture? Are you going to, you could. What if you don't see it? Like, so Jack and Jill went up, you draw 3 little buckets going up the hill, and then on the other side of the hill, you draw one, falling, tipped over. The water's leaving, going away, right? Maybe it's a picture. Maybe sometimes, maybe not in this example, but how many of you have ever done a table to solve a problem before? Okay? How many of you have ever done maybe a graph to solve a problem? Okay? There's a whole slew of different strategies that you can use, but in your plan, this is where you pick that strategy. This is where you decide, okay, how am I going to figure out what operation to use? This, ladies and gentlemen, remember when I talked about solving a simpler problem? If you solve a simpler problem, that is where you can figure out what math am I supposed to be doing, right? Am I supposed to multiply? Am I supposed to divide? Am I supposed to add? Maybe I should subtract. Maybe it's a multi-step problem where I have to add, divide, and multiply. Is that you can also estimate. What if I told you that my estimate was 7 buckets of water? Would that be reasonable? Actually, me why you think that's unreasonable.
Well, because you only started with 3 buckets.
And what happened with buckets? So is there any way that I could get more water after I spilled something?
Yeah. Well, no. Go back to
So this is where you estimate, but you can say, okay, they had 3 buckets of water, some spilled, so how much should be left? About 2. How are you figuring this out?
Like already 1 bucket's like almost fully spilled, so I got at least 2 buckets.
Because did they spill more than 1 bucket? No. They only spilled
2/3.
2/3 of a bucket. Okay, so you guys are starting to think about, okay, what plan? How many of you have already started formulating an idea of what operation you might use to solve this problem? Ladies and gentlemen, your brain is already starting to work through that UPSC process. So now we go on to the solve step. How many of you think that solving is the most important thing? Because that is not true, ladies and gentlemen. Because let me tell you, how many of you have ever seen your parents, or maybe you, use Google Maps? Like you're driving to your grandma's house or something and they put in Google Maps. You're going to your best friend's birthday, you put in Google Maps. What happens if your parent puts in the wrong address?
You go to a different place.
You're going to what?
The wrong place.
The wrong place. Google did it right. You solved it right. He took you exactly where you told him to go. But was your plan right?
No.
Did your parents understand where you were supposed to be going? So do you see where those 2 situations would be more important than this? Because all this is talking about, ladies and gentlemen, this is just the numbers. This is, can you do 5 times 6 plus 5? That's all this part is. It's to understand the plan that sets you up for an easy ride to the finish. Now, how many of you think once you have the answer, you're finished? It's okay. 5 plus 5 is 10. Game over, right? Because there's one last thing after you solve that, and that is to check. And here's why. If you can do this, ladies and gentlemen, this is how many of you have ever said, I made a simple mistake? Right? Ladies and gentlemen, let's fix these simple mistakes by going through the UPSC process of that we actually get there. Because we're checking if it's reasonable. If you tell me that the answer is 7, was that reasonable?
No.
And can you list off 5 different reasons why that's unreasonable? Number 1, we only started with 3 buckets. Number 2, we spilled water. So how can we get more? Someone earlier told me, well, wait a second, if you had a hole and you spilled a part, what should your answer be?
Part.
We should have some sort of part, so we probably are going to have what kind of number? A mixed number. So could 7 be, so are you guys starting to see all the different reasons why maybe this is not a reasonable answer? But ladies and gentlemen, can I do this for you? No. Do I get to go to you on the start test? Hey, you better check that. Do I get to do that? No, of course not. That would be the end of me. That would be the last time you'd see me. Okay? I don't get to do that. So you have to train yourself. Can you check? Can you done that? Okay? Make sure you are answering the question. Did you complete all your steps in your plan? If your plan says, okay, I have 5 steps, then you're going to say, I did steps 1, 2, 3, 4, and if you didn't do all 5 steps, did you follow through on your plan? Then do you remember when we talked about the you, right? And we talked about the I need to find, and we talked about that little statement. At the end, when you check, you should be able to say, I found that, and it should answer that first question that you came up with. And if you can answer that first question, chances are that with a good plan, a good understanding, some correct solutions in your mathematical process, that you can come back here and be sure that you made it. So what we're going to do today, okay, I'm going to pass out one of these little activity mats and some sticky notes. And what we're going to go through is we are going to go through and work through problems together and practice what does it look like to have your understanding and your plan and your solution and your checking. Who's responsible for contributing a sticky note to the map? So when we do it at work, you're going to write down your thoughts, put it on a sticky note, put it on your map. Then we will discuss as a group, in your little groups, which sticky note best matches what we're looking for. Does that kind of make sense of where we're going? So, all right, here's the first problem. I need a volunteer to read this for me. Jaden, go for it.
A baby weighs 7.25 pounds at birth, and at the end of 8 months, the baby weighed 2.5 times its birth weight. How many pounds does the baby weigh at the end of 2 months?
Okay.
What was happening?
What happened? What happened in this problem? A baby gained weight. It was born at this. 8 months later, we know that it gained weight. What you would hope is what a baby would do, right? So, ladies and gentlemen, that's all you're supposed to get from the first time. Believe it or not, that's all your brain really got the first time. Okay? Jane, would you read it again for us?
A baby weighs 7.25 pounds at birth.
Problem.
Yes.
Dylan, what's some information that you got from the problem?
Baby weighs 7.25 at birth.
Beautiful. Okay, so now what I want us to do is I want us to all read this at the same time for the last time, okay? Now is I want you to start thinking, your brain should be transitioning to figuring out what you need to find. You should be able to finish the statement, I need to find that. So let's all read it together. Are we ready? Okay. A baby weighs 7.25 pounds at birth.
At the end of 8 months, the baby weighed 2.5 times its birth weight. How many pounds did the baby weigh at the end of 8 months?
Okay, so what I want you to do now, talk to the person next to you on your sticky note. I need to find ... I want you to come up with a phrase. There's no math here. This is just what is this question asking? When you've completed the statement, go ahead and put your sticky note in the U section of your activity. Come on there. Exactly.
Start with this one.
I need to find the product of the problem. Yours says I need to find how much the baby weighed over 8 months.
Well, you can actually shoot your no pens.
Well, Mathis, he said the same thing, but Mathis is I'm just gonna fold mine up. Okay.
Alrighty, so everyone has one.
Yes.
Devin, what did your group pick?
We picked, I need to find how much the baby weighed at the end of 8 months.
How many of you had something similar? How many of you had something different? I need to find how many pounds did the baby weigh at the end of 8 months. How many of you just wrote the question? It's okay if you did, but we need to talk about this. Okay, but why did you veto that sticky?
Because like it's okay. It says I need to find how many pounds does the baby weigh. It could have been like at anything like 9 months, 2 years old, 8 years old.
Okay, and well, okay, I understand. So do you understand her argument?
Yeah.
That if we don't put the 8 months, then it changes things, right? But let me ask you a question. In our question, is the 8 months really like a game changer?
No.
If we put 2 years, does that change the problem?
No.
No, because you're still going to gain 2.5 times. What? So sometimes you have to phrase your question in a way that maybe considers, is all the information in the question relevant? Because so what I want you to do now, you're going to get your sticky note again, you're going to come up with a plan, put it into your plan box, and then we're going to talk about it as a group. Here's the question again.
2.5. Find the product and a
Really? We keep
And
doing the
find the
same
product.
thing. I think Peyton's.
Yeah.
You got to figure it out.
Oh.
Did we come up with a plan? Did everyone agree in some form or fashion that this is going to be a multiplication type problem? All right, now is the time where it should be rock and roll, ready to go. Solve it out. Again, everyone's doing it on a different sticky note. You're all putting your solve answers together on your map. And you say, okay, like, you know, this is how I did it. This is why I did it. I mean, obviously you all said